Hi. I'd like to introduce Filip Sedla, his presentation, watching TV, so you don't have to. I'm so curious about, because I like to watching a TV as my rest time, during my rest time. So I'm so curious why I can't, or
Well,
you do
you can.
instead of me. Okay, thank you. So stage is yours.
Thank you. Yeah, actually, it will not be only about TV, but radio too. Um, so, I don't. Can we start? Yeah. Oh, so it's there. Oh, sorry. Yeah. First, a quick intro about me. I'm more of a generalist. I studied chemistry. I co-founded a machine learning startup, and I worked at Google, at Twisto, and now I'm helping startups scale up a bit. So at this moment, I work for Media Board. That's a media monitoring company originated here in Prague. And we do monitoring of basically all the media that you can imagine. We are scraping the internet for online news. We are reading print news and magazines. We are looking at social networks. And what this talk will be about is television and radio. So that whenever someone talks about a topic that is interesting to you, about some brand or some industry you work in, then we can notify you, provide analytics, and so on. So that's a tool for PR people. So you're not the target group. But what's interesting with us is that we are dealing with a fairly large amount of data, and we have a fairly big live index, including archived media. So today, I would like to do a user talk about Kubernetes or cloud-native technologies. So how are we using that for this big data processing, where it works well, but where it falls short for us? Because we are quite cost sensitive. We are still a small company. We are now in several countries like Czechia, Poland, Slovakia, Slovenia, Croatia. And we are trying to open one or two countries per year. So we have to look at our costs. So, for example, running everything in AWS is not an option for us because it would be just too expensive. What we are facing quite often is that there are slight incompatibilities between the providers of Kubernetes at OVH is different from Kubernetes at Amazon, different if you rent yourself, and so this is how we are dealing with that stuff. And I saw a lot of talks doing LLMs or AI, how everyone is using it. I'm trying to refrain from that in this talk. So we have been capturing the TV and radio for a long time, basically almost from the beginning. But it was always a second-class citizen because the online and print was the main focus. And now, as the product is more polished, and we are trying to target more and more customers, it's more important, and especially when we are opening new countries. So we thought we already knew how to deal with this data, and we just needed to make it a little bit bigger. So with that in mind, we said, okay, this will be a short project for, I don't know, 2-3 months, and we will just rewrite it, and we are good. We know what we are doing. 1 year later, I'm doing this talk, and we are still not finished with setting up the system as a whole. So this is a story about what can go wrong. So at this moment, we are monitoring about 350 channels, and this is expected to grow at least a double. which is different than our situation in online monitoring, where we currently capture about 5 million articles per day, and we know we don't have to scale much more in that area because there are just not that many articles written globally. We need to be more precise in that area, but we don't need to scale up. So here in TV and radio, we deal with larger amounts of data, and we are growing quite fast. So the workflow that we do is that we need to watch the station, the TV or radio station. We just record the stream of the data. Then we need to get the program. Like we need to know that, okay, today there is news at 7, but during weekend it shifts to 8 p.m., something like that. And we match which of these programs are interesting to us. We have to transcribe it to text. We automatically clip it to stories. So, for example, if you have news at 7 at Česká televize, it's composed of many stories, and each one is an independent article in our system. And sometimes there is a human in the loop who has to verify that this is correctly done, that it starts at the right time, that the people who are mentioned there are those people, and so on. So basically, this is what we need to do. And now, how do we do it? So I don't know. Does anyone of you have worked with media data? Like, how many people? Okay, not that many. I didn't have much experience with this either before. So if you are looking at I don't know, there is this webpage, Radio Garden. I don't know if you know that. You can basically select any station on Globe and just listen to, I don't know, some Italian radio or Arabic radio and so on. So they stream data to us, but how does it look technically? In the radio example, that's like an endless MP3 file that you can just connect with your browser to, and it just plays, and you download it in real time, and you get an endless stream of bytes. But this is quite unwieldy to store. You cannot store an infinite file in your system. How would it work? So in order to deal with that, there are some streaming formats that deal with this problem. That there is HLS, which is from Apple, and it's the simpler one. You have a playlist of segments. So, for example, here in this example, they cut it to roughly 9 seconds. And each of these segments is an independent media file that you can play, and the client just refreshes this playlist, and you store those media files in CDN somewhere, and that's your streaming. There is a competing format, MPEG-Dash. It's ISO standard, much more complicated. Yeah, it works basically the same. You also chunk it to some periods of time, and you deal with small files that you have to then stitch together if you want to play them. So what we had in mind at the beginning was that there's this stream. We have a recording box that cuts the stream into chunks. Stores some metadata into SQL database, and then the main system wants a clip for a specific time, and this recording system can give it to the main one. There are a few issues with that. One thing is that when you're scaling up this thing, you want to parallelize it ideally per channel because they are independent, and not to have everything in a like single monolith. That was easy to start with. It was easy to develop, but we had to then carve out some responsibilities to external systems. Uh, One thing you have to deal with is the uptime. If you are crawling online articles and you are down for 5 minutes, nothing happens basically. If you are down for 5 minutes when you are listening to radio or watching TV, the data is gone. You have to then fetch it somewhere from the archive after it is available. It's a pain. So there are real like uptime requirements for this kind of service, and you want to contain problems to like single channel ideally. The other thing is the storage. You don't want to rely on local storage again because of like losing the storage means that you just don't have the data, and you also are tied to specific box. The problem is that there's quite a lot of files. If you have just 100 channels and keep them for 2 weeks, it's 12 million files, and that means like if you have 100 channels, that's 10 uploads per second. So now we are doing about 40 uploads per second. And to our surprise, this was already enough to break, for example, Hetzner object storage. And I don't know if it was related to our issues, but sometime during the beginning of this year, a part of the documentation in Hetzner started to say that, oh yeah, this service is good mostly for archiving and not frequently accessed data. Us like rewriting 12 million files every 2 weeks or even more, it was not a good use case for that. So at the beginning we thought, oh yeah, so let's use object storage. There's many providers of this kind of service, compatible API, but they are not all made equal. Now we are using Backblaze. It's workable. It's not as good as Amazon, but for a fraction of the price. So we are using that for now. And we split the system into like multiple stages. Most of them are modeled as Kubernetes deployments running in parallel, maybe in several replicas. And at the beginning, there's the recorder box that has its own storage. It caches about 1 hour of stream, because the problem in the beginning was that we were depending on a central database to store the metadata. So now we split it up, and even if our database is down for a short while, we still have like 1 hour to catch up with the recorded media. So that gives us some leeway, and it's a balance that there is a very simple recording box. We have different provider formats that are implemented there. It normalizes the data, but doesn't do much more. So it's also something that's quite easy to do with Kubernetes. The problem is that those things now need to communicate with each other, and I'll get to that a bit later. What are the issues with communication with different Kubernetes clusters? So there's a slight aside that we didn't have that much experience with media formats, and there was one issue that bothered us for quite a long time, that because there are different streams in the media file. There you can have video and audio if you are watching TV, and we had problems synchronizing that. If you then assembled those small chunks, um, the audio and the text was slightly off compared to the video, and we couldn't figure out why was that before we really understood how the media format works, and the synchronization was getting more and more wrong the longer video you had. So the issue, if someone is dealing with that, was that when you cut to 10-second files, they are expected to be not independent. They are dependent on each other because the sound and the picture can not be can not end and start at the exact point in time, and this is expected because if you then stitch this together and you say that okay, here I remove the gap here and I remove the gap here, then everything works perfectly. But if you reset the timestamps like we inadvertently did, and just put the files together like independent video files, then one stream might get those gaps, while the other one might stitch perfectly together, which gets you a very short delay every 10 seconds, and then after several minutes, it's visibly off. So if you're working with media files, there are several different layers of timestamps. You have a timestamp that tells you when a particular frame should be shown up, when it should be decoded. So yeah, something that I didn't think I might need to know. Now we are dealing also with multi-cloud and multi-region. We didn't want actually multi-cloud, but we were a bit forced to, because the providers of the signal, they sometimes require that we consume the signal in a specific country. So, for example, if you are recording Croatian TV, you have a contract that says, "Oh yeah, but we deliver only to Croatia," because that's what their copyright allows them to do. So we need to be present at several regions, several countries, and again, we cannot do it really with just AWS or Google Cloud, because just transferring all the data across those clouds would be too expensive. So we are somewhere we have our own hosted Kubernetes. Somewhere we use, for example, OVH. And the thing is that each provider gives you a slightly different way of doing things, which is sometimes a bit problematic. For example, setting up firewalls and so on. Storage. This is the other thing that doesn't match perfectly everywhere. One thing I wanted to mention here is that in this system, we do stateful rollouts. So like stopping background workers, do changes in the database, update web workers, start the background workers anew. This is something I see a lot of people are moving to GitOps, but not many people are talking about how they are dealing with this kind of problem. So that, yeah, you want to have a source of truth in your Git, but how to get there might be a stateful process. So I would be really interested after a talk to talk to any of you who who are dealing with this issue, and how are you solving that? Because we don't want every of our versions of code be fully backwards compatible with anything that might be running in production. So we try to minimize the time when it might cause issues, and we are trying to just just make it easy to deploy new things to database, because our database changes almost daily. And if we did stateless rollouts, just deploy anything that is the new version, that would mean slower development, because you would need to phase out the change of the database in a different change set than change of the code that depends on it. So yeah, if anyone has experience with this, I'm interested to talk to you. So here I actually like working with Kubernetes for this use case, because even if it's not 100% equal, still it gives us cross-cloud portability. And because we have quite a bit of channels, and each of them has its own deployment and ingress and so on. We really like the programmability that this does. So our application acts as a Kubernetes operator, and based on our database state, it starts or stops the Kubernetes deployments. So yeah, this is the story how we are using Kubernetes for watching a lot of channels and scaling up. We thought it would be an easier problem. We didn't know about the issues that we would encounter, for example, with the legal stuff around copyrights. We didn't know about the slight inconsistencies between different providers. But if anyone has any question, I'm here to answer. Thank you for your attention.
There are no questions. But definitely ask me. Maybe I will help you a little bit with the problem.
Okay.
Maybe another way. Maybe we find 2 or 3 solutions. It'll be fine for a discussion. And thank you for your time and share your project.
Thank you. So if no one has questions, I have questions for you. One is the one that I already asked about the deployment story. So currently we are doing a Python script that generates the manifest and does this stage rollout. But our infra people don't like that, because it's not like standard tooling. And the second question, like, what is your experience with multi-cloud, and how do you deal with networking? Are you using public internet or VPNs to connect between clouds, and just how you do it? So if anyone wants to share with me, just please find me out. Thank you.